Okay, so hi everyone. So today we are going to discuss the previous year week 2's assignment, and if you have any question, any doubt, you can discuss in between, and we will be solving around 10 questions from previous year's assignment 2. Okay, and let's start. So I will be those who are joining here for the first time, my name is Vishakha Pandey. I'm PhD student uh, for electrical engineering. Okay, all right. I am working on antennas. So let's start the session. So the first question is the finite sheet 0 uh, x in between 0 to 1, y in between 0 to 1 on the z is equals to 0 plane has a charge density rho s is equals to xy in brackets x square plus y square plus 25 to the power 3 by 2 nanocoulomb per meter square. Using the information to solve question Use the information to solve questions 1 to 3. Alright, so the first question is for 2 points. I will try to make you understand in Hindi as well. So the question here is pretty simple. A sheet is given, all right, and some dimension of x and y is given. Here x and y is from 0 to 1. Okay, sheet is given, and a density of the charge on this sheet has is given, and using this information, it is asked what will be the total charge on the sheet. सो या तो चार एक शीट दी हुई है एक्स से लेके एक्स और वाई जिसका 0 से लेके 1 के बीच में है, जेड प्लेन जेड इज इक्वल टू 0 प्लेन पर है और चार्ज डेंसिटी दी हुई है, ठीक है, और पूछा है कि टोटल चार्ज क्या होगा. तो टोटल चार्ज निकालना है अगर किसी शीट का. सो कैन समवन फ्रॉम यू टेल मी हाउ टू सॉल्व दिस क्वेश्चन.
Ma'am,
Yes, go ahead.
integral rho s into ds, ma'am. Q is equal
Yes.
to integral rho s into ds.
Yes. Good. What is your name?
Gokul, ma'am. Gokul.
Okay, Gokul. Good, very good. So before answering anything, you just tell me introduce yourself, and then tell me the answer. In that way, it will be more interactive. I will be knowing you personally whom I'm talking to. Okay. So yeah, so the extent of charge sheet is x is in between 0 to 1, y is in between 0 to 1. Then the surface charge density is given as rho s is equals to x y in brackets x square plus y square plus 25 to the power 3 by 2 nanocoulomb per meter square. Then the total charge on the sheet will be double integral of one integral for dx, another for dy. This is the formula rho s x comma y dx dy. Okay, so now we know rho s. So putting the value of rho s x comma y, we got x y in brackets x square plus y square plus 25 to the power 3 comma 2 and double integrals it is in and from 0 to 1. Okay, now solving this question, we can put x square as p and y square as q, and then we can solve this. So total charge is equals to q plus p plus 25 to the power 3 by 2 dp by dq by 4. And we can solve this. It's a pretty simple integration question. And if you solve it, put the values 0 to 1, so we got 33.15 nanocoulombs. So total charge here is 33.15 nanocoulombs. So option C. Okay, one second. Option C is the right answer. Okay. So is there any doubt in this question, or should I go ahead? Okay. So since no one is answering, I will go ahead. Now for the same information, that is a finite sheet is given, plane z equals to 0 plane is given, charge density is given, and we have found out the total charge. Now the second question is, what will be the electric field at 0 comma 0 comma 5. So here, if a sheet is given like this, okay, so here it's a plane of z is equals to 0 and point is 0 comma 0 comma 5, and the electric field intensity is asked. Here the charge is given. Okay, all right, one second. Okay, and this is asked. Sorry, my drawing skill is pretty poor, you can see that. Okay, so anyone can tell me how to solve this question? Is there anyone?
Rho s divided by 2 epsilon into a n vector.
You are not audible. Your voice was breaking in between. Can you introduce yourself and then tell me what you are saying?
Gokul ma'am, Gokul.
Ha, Gokul. Acha. Hi, Gokul. Yes, go ahead.
E is equal to rho s divided by 2 epsilon into a n vector.
Yeah. Okay. 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 So yeah, let's go. To find the electric field at P is equals to 0 comma 0 comma 5 due to the charge sheet, consider an infinitesimal area element dA is equals to dx dy. Okay, this is a dy. Sorry, I have it's a dy whose coordinates are x comma y comma 0. Then the position vector from the element dA to point P will be given as, so the point here is x comma y comma 0. So and the point P is 0 comma 0 comma 5. So what will it become? 0 minus, it will become 0 minus x, isn't it? Then a of x, right? Similarly 0 minus y and 0 minus y and 5 minus 0. So we got this. Okay. Now the modulus of this vector will be, yeah, we can find out the modulus of this vector will be x square plus y square plus the z, the element of the coefficient of z, that is 5 whole square, under root, overall under root, so x square plus y square plus 25 to the power 1 by 2. This will be the length of the vector. Then the total electric field at P due to the charge sheet will be given as integration, double integration 1 upon 4 pi epsilon naught rho s r upon r cube. This is the standard formula for electric field intensity. Now putting the values of rho, uh, okay, here, sorry, putting the value of r, not rho, putting the value of r here directly, we got, and the value of rho s, we got xy whole bracket x square plus y square plus 25 to the power 3 by 2, putting all the values that we have got from here. We will be solving the question. It's pretty same. Again, the integrations are given here, integral signs. And if you will put the value 0 from 0 to 1, from 0 to 1, from 0 to 1, and we will get this. Okay, so this will be the electric field intensity. Okay. So the quantity within the brackets is in units, nano coulomb per meter square, but here it has asked in the SI unit, volts per meter. So we will be converting it. Okay, that is uh, for nano we will be converting it and converting the coulomb per meter square into volts per meter, and this will be the value. So the electric field intensity will be this. For the same information which is given, what will be the force experienced by -1 millicoulomb charge located at 0 comma 0 comma 5. So now you know the total charge, you know the electric field. Will you be able to find out the force experienced by this charge, -1 millicoulomb charge? Will you be able to find out that? And if you will be, how?
F is equal to Q into E.
Yes, yes, very good. Gokul, is it?
Yes, ma'am. Yes, ma'am.
Okay, okay, yeah. So very good. Yeah, so charge is equals to -1 millicoulomb placed at point P. The force experience will be Q into A. So put the values here and multiply it. You will get it in millinewtons. Okay. Now, uh, yeah, let's go for question number 4. So question number 4 here is a charge distribution with spherical symmetry has density rho v is equals to rho r upon r, and here the small r is from 0 to the capital R. Using the information, solve question number 4 to 5. So the question here is it's a sphere, okay, and it has a density rho v equal to rho naught small r upon capital R, and the radius of the sphere given is something like this. Okay, so this is capital R, this is capital R, and R is in between. Okay. The electric field for R less than small r less than capital R is. Okay. So charge distribution is given. The density is given to us. The electric field is asked. Okay. Yeah. So now let's try to solve this question. Okay, so given that rho v is equals to rho naught r upon r, small r upon capital R, for r less than small r less than capital R. Now Gauss law states that the electric field E at surface S of an enclosed volume V is given as integral of E dot dA is equals to Q enclosed upon epsilon naught. ओके, तो सिंपल सा एक हमें रो वी दे रखा है, डेंसिटी दे रखी है चार्ज की, एक स्फेयर दे रखा है, हमसे पूछा है कि इलेक्ट्रिक फील्ड इंटेंसिटी क्या होगी अगर जो हम वो पॉइंट लेते हैं जो रेडियस से छोटा पॉइंट है, रेडियस के अंदर है अगर, तो स्फेयर के अंदर इलेक्ट्रिक फील्ड इंटेंसिटी क्या होगी. बेसिकली क्वेश्चन ये है. ठीक, Gauss law की help से we can, it will be very easy for us to solve this question. Okay, here Q enclosed is the total charge enclosed within the volume V, and phi s is the surface integral, integral S is the surface integral area of the surface S. In this problem, the surface is that of a sphere of radius r. Here small r. Okay, centered at the origin. Hence, an infinitesimal area of this surface is dA is equals to dA vector r, unit vector r. The symmetry of the problem, we know the symmetry of the problem. So electric field intensity can be written as this. Since why it can be written as this? Is it this? Because our the surface is symmetrical, and from every point of this sphere will have the same electric field intensity. Okay, yeah. So now dA will be 4 pi r square, since the sphere, we know the surface area of the sphere, that is 4 pi r square. So yeah, now we will try to solve this question. Yeah, we got this. Rho depends only on r. So the closed here we have already seen that rho v only depends on this r. Okay, so since rho depends only on r, q enclosed will be rho naught upon r integral r dot 4 pi r square dr to dr from 0 to r. Okay, we will solve this question and we will find out the electric field intensity. Is there any problem? Is there any doubt you have, or should I go ahead? It's pretty simple integration. You have to do it from 0 to r. Right? All right. Okay. So I will go next. Next question is, if rho v is equals to 0 for r greater than r. Okay. So it is saying that the surface has rho v, some density. Surface, this sphere has some density, but outside this sphere there is the charge density is equals to 0. Okay. Now the electric field will be. Okay, so rho v outside the sphere is equals to 0. Then for r greater, small r greater than capital R will be, q enclosed will be same, rho naught upon r, 0 to capital R dot 4 pi r square dr. So here why we have written capital R is, so if the sphere is this, and if uh, okay, so if the sphere is this, and at this point what will be the electric field intensity? Okay, so now this is small r and this is capital R. Okay, so since the whole charge density is in between the sphere and not outside the sphere, the total q enclosed will be this plus small r to capital R, sorry, yeah, capital R to small r, 0 dot dr. Okay, so integration of 0 is 0. So we will then it's a simple integration. Yeah, and so we got the q enclosed, then e will be q enclosed upon epsilon naught upon a, so the surface area, that is 4 pi r square, and the q enclosed upon epsilon naught. So the electric field intensity will be this. Okay, all right, do you have any question? Okay, now let's go ahead. All right. So question number 6. Which of the following is 0? Gradient of divergence, divergence of gradient, curl of gradient. Okay. So can someone tell me what will be the logic behind the solution and what will be the solution? Okay, all right. So here the answer will be curl of curl is 0. Why? Because the formula of curl, put the formula of curl. So curl of curl will be 0. Here x, y, z, uh, del by del x, del by del y, del by del z, del of del x, del by del of del y, by del of del z. So now if you will solve this question, you will get, if you will solve this matrix, you will get 0. So the curl of curl will be the option which will be 0. Okay, option C. So, arre, sorry. Any question you have? Should I go ahead? All right, let's go ahead. What about Gauss's theorem is correct? So it's a simple question. It's asked that uh, what what is Gauss theorem, and like what about Gauss theorem is correct? Gauss theorem की क्या चीज करेक्ट है इसमें से बताओ. ऑप्शन दे रखे हैं. पहला ऑप्शन है इट कैन नॉट बी डिराइव्ड बाय यूजिंग कुलम्स लॉ. सेकेंड, इट इज नॉट वैलिड फॉर कंजर्वेटिव फील्ड obeys inverse square root law. Third, Gauss theorem is applicable in gravitation. Both A and B. Now, what do you think? What if you have any answer, if you want to discuss something, you can tell me.
Gravitation, ma'am. Gauss theorem is applicable in gravitation.
Okay, why do you think so? Yeah, okay. Gauss theorem is it's a pretty common sense वाली बात है. It's a Gauss theorem is applicable in first is कि since the charge uh, for Gauss theorem the charge can also be replaced by mass and the gravitational pull is the force. So Gauss theorem is applicable in gravitation. And second thing is it cannot be derived by using Coulomb's law. That is wrong. It can be derived by using Coulomb's law. Second is it is not valid for conservative field obeys inverse square root law. So that is also wrong. It is valid for conservative field and it obeys inverse square root law. Okay. So both A
Ma'am,
and B. Huh. Hello.
ma'am,
Hmm.
what is inverse square root law, ma'am?
Inverse square root law. Okay. So let me 1 second. Huh? Okay. So let's say that we have a charge Q here. Okay. And this is the surface. Oh, let's make it. I will keep on dotting it and it won't. Huh. So this is the Q enclosed and this is the surface and this is the electric field intensity coming out of it. Okay. So first thing is what is the Gauss law? Gauss law is flux, total flux, that is E, let's say E dot A, keep it simple, is equals to Q enclosed upon Q enclosed upon epsilon naught. Okay. Here E can be written as 1 upon 4 pi epsilon naught Q enclosed upon, let's say we are taking it for point R here, then Q enclosed upon R square. So the inverse root square law is, it is the intensity मतलब basically if anything is inversely proportional to the distance squared, that is r square. If anything is proportional to inversely proportional, let's say the intensity of electric field or something else, so the inverse square root law basically says that if this yeah, the intensity is inversely proportional to the square of the distance, then it is known as this square root law. Okay, so yeah, yeah, one second. Okay, so q enclosed upon epsilon naught a. Yeah, so here a, if you see the sphere, this sphere, the sphere can be written as sorry, the sphere can be written, the surface area of the sphere can be written as 4 pi r square, isn't it? So from here we know this formula, and from this formula also we can find out the same thing, that is E is equals to q enclosed upon epsilon naught, q enclosed upon f, get, you got it right, upon a, and a here is the surface area, that the surface area of the sphere, that is 4 pi r square. So 1 upon 4 pi r square. So basically electric field intensity you got it, which obeys the inverse square law. Yeah. All right. So is there anything else you want to know, or should I go ahead?
Ma'am,
Mm-hmm.
Coulomb's law follows the inverse square law, ma'am. Coulomb's law
Haha.
is also follow inverse square law.
Yes.
F is
Yes.
directly
Yes.
proportional to 1 by r square, means it also obeys
Yes.
the inverse square
Yes.
law.
Yes. Yes. And
Okay, ma'am.
yeah. Yes, it does. And it yes, and by Goulomb's law, Gauss theorem can be derived for from this the thing that I have derived from there also. Gauss theorem can be derived. So only thing which is correct here is Gauss theorem is applicable in gravitation. Okay, next question is divergence theorem is based on. So can someone tell me what divergence theorem is based on? Okay. Hmm. Yeah, so here the divergence theorem is based on Gauss law. Okay, and option A, uh, Gauss law, and option A is Gauss law and Stokes law. That's option A is wrong. Gauss law and Ampere law, that is also wrong. Stokes law, that option is wrong. None of these. So divergence theorem is based on Gauss law, and option is not given. So option will be none of these. Okay. Okay. So next question is, which one is not correct? First is the Gaussian theorem for a line charge will be cylinder. The Gaussian surface for a point charge will be sphere. The third option is the Gaussian surface for a point charge will be cube. All of these. Can someone tell me what will be not, will, what option is not correct here? It's a pretty simple question. I expect you to know this question, yaar. Okay, all right. So see, the first is Gaussian surface for a line charge will be cylinder. Yes, it's a perfect. It will be a perfect Gaussian surface. It will have a here, to define a Gaussian surface, you need to understand two things. One is that it should perfectly enclose, the Gaussian surface should perfectly enclose the charge. So for a line charge, the cylinder will be perfectly enclosing the charge. One thing is that. Another thing is the electric field lines crossing through the Gaussian surface. Uh, it can cross only once. Only those will be termed as Gaussian surface where electric field lines will be passing once. Okay, so here the Gaussian surface for a line charge will be cylinder. Yes. The Gaussian surface for a point charge will be sphere. Yes, correct. The Gaussian surface for a point charge will be cube. Yes, that is also correct. But here what uh, here what we have to see is the symmetry. Okay, so the symmetry here is cylinder for a line charge. Since line charges will be symmetrical, it will have a cylinder as a Gaussian. So second, for Gaussian surface for a point charge, uh, sphere will be the perfect, will have a perfect symmetry. And similarly for a point charge, cube won't be symmetrical, as much symmetrical as a sphere. So the Gaussian surface for a point charge will be sphere. It will be perfectly symmetrical. That's it. Gaussian surface for a point charge can be a cube as well, but it won't be perfectly symmetrical, and we won't be using a cube as a Gaussian surface for a point charge. All right. Is there any other question that you have, or should we move to the last question? Okay. The last question here is, the electric field due to an infinitely long straight uniformly charged wire at a distance d is inversely proportional to. Okay, it's a small it's a very easy question. Here infinitely long straight wire is given which has a uniform charge all over it. Okay, and electric field is asked at a distance d. ओके, तो एक सिंपल सा लाइन वायर दे रखा है जिसपे यूनिफॉर्मली चार्ज है, वो इनफाइनाइटली लॉन्ग है और इलेक्ट्रिक फील्ड पूछा है एट अ पॉइंट डी. ओके, सो लेट्स ट्राई टू सॉल्व दिस क्वेश्चन. पॉइंट डी और पी, इट्स अ पॉइंट डी, है ना, एट अ डिस्टेंस डी. Huh. So let the infinite wire have a charge per unit length. Okay, let's make a, it has a charge per unit length of lambda, and we assume that it passes through the origin. Okay, and is parallel to z axis. We use a cylindrical polar coordinate. Okay, so the Gaussian surface S is cylinder of radius r, and the wire passes through its center. From symmetry of the problem, E electric field at point P is in the radial direction, that is E is equals to E R, and if L is the length of the cylinder, then the curved surface area will be 2 pi RL. This is for a cylinder, the curved surface area for the cylinder. Okay, so the charge enclosed within the cylinder will be, Q enclosed will be lambda into L. Since lambda is here charge per unit length. Okay, now using Gauss law, EA will be Q enclosed upon epsilon naught. Okay, so put A here, so E will be lambda L upon epsilon naught into 1 upon A. A here is 2 pi RL. So E is equals to lambda upon 2 pi epsilon naught R. So when R is equals to D, then E will be lambda upon 2 pi epsilon naught D. So here E is inversely proportional to D. Okay. So here option D will be the correct option. Okay. Yeah. Any question you have? No? Okay. Yeah. If you have any question, you can ask me right now, or I will post the video on YouTube and you can check the video. And if still you have any question, you can ask me there, put it in the comments or something, or you can ask if you have any question in the next session as well. So if you have any question, you can ask me. ऑल राइट, ठीक है, फिर कोई क्वेश्चन कुछ डाउट होगा तो यू कैन आस्क मी, कभी भी पूछ सकते हो, कोई प्रॉब्लम नहीं है. रिपीट द क्वेश्चन 1 2 3. Okay, I have recorded the session and I will put it on YouTube, so you can directly see from there. If you want, I can put the link of my drive there here. Okay, okay, all right. I will. Yeah. So I will. It is recorded. It will go on YouTube, and the YouTube link will be shared with you. Yeah, Vishakha Pandey. Yes, Vishakha Pandey, and you can go and check there. Okay. All right. Yeah. Welcome. ठीक है. So all the best for week 2 assignment which you will be solving, and okay. Bye. Nice meeting you all.
Thank you, ma'am.
Thank you, ma'am.